Alright guys, last time we built this tree from this list of numbers. Remember, we picked the first number and made a root. When we found a number that was bigger, we went to the right and put it down. When we went to the left, it was only with a smaller number. If you look at this tree, you can notice that each subtree has the same overall shape. Look at this 18. To the right is the 20, to the left is the 17. This isn't terrible. This is actually a great thing, because that means the whole tree is organized this way. Now, it's one thing to be able to do this by hand, but we need to be able to do it in code. So what we're going to do is kind of sketch out a little bit of code to do this. It's going to be well, a little bit tedious. So what I'm going to try to do is show an outline first and then go into the code next. So my outline is going to kind of go like this. When I first start off, my first number is going to be the root. So let's see, what do we have here? I'm going to make a loop, and I'm going to do it like this. I'm going to go while I have numbers in my list. I'm going to grab a number, num equals get number. If it's the first number, I have to establish my root. So like this, if is the first number, root equals make tree node. Something like that. Kind of like that. If it's not the first number, then I have to find where it's going to go in this tree. So I'm going to have to go into a loop to do that. So I'm just going to write this down like this. Else find where number goes. Where number goes. Oops, something like that. Once I find where it goes, I need to insert it into the tree. Insert number into tree. About like that. So these two pieces here, these are kind of the key, right? So what I'm going to do is I want to follow this general outline. Whoops, you can't quite see that. I'm going to follow this general outline, and I'm going to try to write it out as a good bit more detailed. So we're going to switch pages and do that. We're going to try to write it out, and you'll have to bear with me. Hang on. Let me switch pages. What we'll do first is we'll figure out how to find where the number is going to go. So like this, let's say we'll have a type tree node. just call it cur. And we'll have some things. Then we'll set cur to root. Cur equals root. And then we're going to have essentially a small search routine. I'm going to write this out, and I'm going to leave out some of my variable declarations, but here we go. We'll go like this. While searching, let's see. I left something out. Whoops. Num equals get number from list. Sorry about that. So while we're going to go into this loop, we're going to find where number fits in to our tree. So what we want to do is compare number to each data piece of the tree. So it's going to be like this. If num is equal to cur.data, for now we're just going to say mark as duplicate here. Mark as duplicate. Like that. If it's a duplicate, well, we have found where it's going to go, so we're going to turn the search off. Searching equals false. Like that. Now, what we're going to do is this. If num is less than current.data, well, if it's less, we want to go left. So we're going to say cur equals cur.left. Now I'm going to kind of hedge my bets a little bit here, because I'm just writing this out simply. And we'll get more detailed on the next page. And I'm going to go one more part of this if statement. Actually, this one here should probably be an else if. Else if, like that. Else if num is greater than cur.data. Like that. Cur equals cur.right. Now, so if I structure this search like this, for now I'm just gonna well, I'm not gonna end the search, but I want to talk about it a little bit. So if it's equal, we have found a duplicate. If it's less, we want to go left. If it's greater, we want to go right. What we're leaving out here is if there is not a node to the left or to the right. For instance, let me draw a little baby tree here. 17, 8, 22, 11. Suppose I'm looking for a place to put a this is hard. Let's see, it's got to be greater than 8 and less than 11. Suppose I'm looking for a place to put a 9. There's the number I want to insert. 9 is less than 17, so I follow this branch. 9 is greater than 8, so I follow this branch. Now 9 is less than 11. I can't actually follow this branch. If I do this one right here, cur equals cur dot left, well, this is pointing to null. So I have to check that. So in each of these spots, I really need to check for null. Actually, before I go that way. So we're going to rewrite this and take that into account. But the general structure is almost exactly the way we did it before. We set current to root, we go into a search. If our number is equal to current.data, we found a duplicate. If the number is less than current.data, we go left. If the number is greater than current.data, we go right. Now, where we have a kind of a mistake here is, I wouldn't even say it's a mistake, it's an omission. If we can go left, we want to go left. If we can't go left, well, that means we've found where the number is supposed to go, and we put it there. Same here. If the number is greater than current.data, we go right. If we can't go right, that means we've found where it goes, and we create a new branch right there. So let's try to fix this situation with a little bit better piece of code. And again, when I sketch it out, it's going to be very pseudocodish, kind of like this. Whoops! What is that? A bug. Okay, I got him. Oops! Yeah! Oops, that made a mess. Stand by, folks. I got this. Ooh. Oh, wait a minute. That was actually not a bad bug. He's a good bug. So we'll just... Oops. Got a little bit more mess. We won't get rid of him all the way. He's a good bug that bleeds a lot. Alright, so now we got that part over with. Let's try this again. This time I have to put it a little bit like this so I can write good. This time we're going to do it a little better. So here we go. We're going to say tree node like this, tree node, and we're going to have two tree node variables, root and cur. And then we're going to have another variable called searching. That's a Boolean. Now remember, we're getting passed in here essentially just a list of numbers. Like this, 8, 6, 7, 5, 3, 0, 9, something like that. So what we're going to do is, we may as well do something like this. Num equals get num from list. Something like that. Now, since we're just starting this off, we're going to go like this. Root equals make tree node num. So now we have pretty much established our root. Everything that comes after that is going to be inserted somewhere under this tree. So now we'll set searching equals true. And, well, let's not do that. I'll scratch that out. I'm gonna go into my while loop right now. or a for loop. How's that? For j equals 1, j is less than list dot length or something like that. So I'm starting at 1 because I already put the root in there. Like that. Now I'm going to say num equals get num from list, like this. Ugh, y'all can't read that, sorry. And I'll say searching is true. Searching equals true, and then I'm going to go into my loop. While searching. And I also just messed up again. I'm going to set cur equal to root. There. So what I'm going to do now is just essentially find where this number is going to go. So I'm going to do the same thing I just did over there. If num is equal to cur.data, I'm just going to put a comment here. Mark as duplicate. Now I'm going to turn the search off. Searching equals false, like that. Now I'm going to do this for the branch to the left. Else if num is less than cur.data, like that. Now this is where I'm going to do my check. If cur.left does not equal null, cur equals cur.left. So if I have a path, I'll take it. Otherwise, that means I've found where I'm going to put the number. So I'm going to go like this, else cur.left equals make tree node. Ugh, running out of paper here. Boom, right there, like that. Yep, maybe you can see that. I have one thing left to do here, and that's turn off the search. So searching equals false. So let's do this. Now we're going to do the same thing with the right side. Else if num is greater than cur.data, I can't fit all that in there. So what I'm going to do is go right up here, and I'm going to outline this for you. And we're going to put something just like that here, except for we're checking the right side. Check the right side. So if we look at what we did here, it's almost the same as what we talked about before. Here, we grab a number from the list. We create our tree by making the root. Now we go into a loop here, Let me see if I can get that a little better for you. We go into a loop here that's going to go just for the length of the list. Each time we grab a number, we set searching to true, we set current to the root. Then we go into a while loop that's going to find where our number is going to live. If the number equals current.data, we found a duplicate. We can mark it as a duplicate, or we can just say, hey, I found a duplicate, and turn the search off. If it's not a duplicate, we have to traverse the tree. If the number is less than where we're currently sitting, we want to go left. Here we say if current.left does not equal null, that means we can go left, so we set current to current.left. If we can't go left, we make the node and we turn off the search, and then we'll just go up and get the next number. If the number turned out to be bigger, then we have to go right. And we'll do it just the same way as we did this, except for we'll say if current.right does not equal null, current equals current.right. If it is null, we'll set current.right to a new tree node, and we'll turn off the search. Simple as that. I hope this helps, and sorry about the bug mess.